Okay, welcome people. This is the last Algebra 2 video lesson for this semester. So for here we're in 9L and we are ready for solving radical equations, one last one. So you can kind of just write that down. And I know that I gave you one that had other something else here, like I think a plus something or something else here. Could you white that out, or could you write over it or you can wait for tomorrow. I can give you one of these. I'll just probably have one of these in the final, so I know it's a little bit towards the ends, but you know, it's something that we've gotten used to already. So let's just go ahead and get started. A radical equation, an equation that has a variable in the radicand. So like this, if you notice here that the w for the variable is inside the radical symbol. When you have that, you have yourself a radical equation. Now with the other one, however, this other one here at the bottom, this one has the radical with the 5, but then the w by itself, no radical. So that's not a radical equation because it's not contained within the radicand, which is another word for what we call the radical. Alright, let's start with the first nice one here. Let me show you two different things and then this concept that will be important here. We're going to do this entire left side and then you can practice on the other side over there. And then I'll show you the worksheet that comes with this as well. Now, let's finish this guy off here. So this guy is like this. Of course, you want to do reverse PEMDAS. Reverse PEMDAS means that when you're solving equations, you're doing PEMDAS in reverse. So this is what I mean. You want to always, when I highlighted all these radicals, because you want to isolate them. You want to have them by themselves. So you see that 7? That's getting in the way. It's like an addition, subtraction. That's what you get rid of first. And you get something like this. Now, I need you to understand one thing. When you have this square root, you can undo that with a square. You gotta understand here. Let's write it here. X to the power of 2, like a square, undoes a radical. They are inverse operations. Please write that. Inverse operations. Now, why is that important? Well, when you're doing this solving for equations in general, you always do inverse operation. You see this one right here? This is an inverse operation. Positive minus 7. Okay, both sides of the equal sign. So here you're going to now do a new inverse operation, which is squaring. When you see a radical, you're going to square. That's your operation. Now, why do you do that? Well, this inverse operation cancels this. So you're left with 5x equals 9. Now, this is going to give you a fraction. Nice little fraction for a final answer here. Divided by 5, divided by 5, cancel, cancel. X equals 9 over 5. We can just kind of circle this. There you go. So it's a nice radical. That would actually make this true. You plug that there, you take the square root, you get 10. Okay? Now, sometimes some radicals give you one solution and sometimes they give you two, but there's this thing called extraneous solutions that have to do with some of the solutions not being an actual solution to the original equation. Now, it all has to do with this. You gotta just use a principal value, which means the positive square root value. I'll show you what this means when we solve for this guy here. Okay, so let's go ahead and solve for this. Now, you see here that my radical here is isolated, so we can go ahead and undo this radical, this square, with a square root to both sides. You got something like that, you go continue. X squared equals this guy cancels that, so you get 4x plus 5. Now this is a quadratic, you just got to rearrange it to one side. So x squared equals, oops, not equals there. Sorry about that. Where's my, really quick here. Okay. So minus 4x going to the other side, minus 5 equals 0. This is a nice quadratic here. You can factor. Let's factor this. Okay, x negative 5, x plus 1. Perfect. Like that. And you can quickly check, add them, you get that. Multiply them, you get this. Nice. So there you go, factored. And then now solve for each. This one will give you x minus 5 equals 0, and the other one will give you x plus 1 equals 0. Minus 1, cancel, cancel, plus 5, cancel, cancel. X equals 5, x equals negative 1. So now you have two solutions, but you have to check whether they're both going to be valid here. Now this is how you check. First with 5. So you just take this guy, the original equation, bring it over here, and you do 5 equals the square root of 4 times 5 plus 5. So this gives you 5 equals square root of 20 plus 5. 5 equals the square root of 25, and that's exactly right. 5 equals 5. Check. So this guy is a check. Now let's try the other one. Negative 1. Negative 1 equals the square root of 4 negative 1 plus 5. And then you get negative 1 equals square root of negative 4 plus 5, which equals the square root of 1, negative 1. We have a problem here. Now, the principal root value is this, that we know that if we take the square root, we technically should get a plus or minus 1, okay? But principal root value means, or principal value, or positive square root means we're only going to use the positive, not the negative. The negative doesn't count. So when you take the square root of 1, it's going to be only 1. And negative 1 does not equal 1. So this right here is an extraneous solution. So we cross this out. It's not part of the solution, and we say extraneous solution. So we only have one solution. Even though we did this correctly and we got two solutions at the end, you have to do this with some radicals that give you two solutions. And actually sometimes they both work. If this guy worked out, he would be part of the solution, but only him, because only him worked out. Sometimes they do both, sometimes only one, and then usually it's never none of them. So at least one. Okay, how about this one right here? Solve each radical equation. So let me go ahead and just finish these two here, so that you can do something like this. Okay, you see your little setups there. I kind of highlighted your equations and then how to start. Okay. Now for these two, I do want to see this. This is a little bit lengthy video, but let me try to solve it here, so that we're almost done with this one here. So we do that, divide by 5, square root of x equals 3. Now both sides you're going to square, because that's how you undo this, cancels this. X equals, and that's a nice 9. Okay, that's a nice one. That's a nice answer, and it should work out. Square root of 9 is 3. 3 times 5 is 15. 15 plus 7 is 22. Nice. Worked out just fine like that. Now let's do this last one here. This one's a bit lengthy here. So this square cancels the radical. You get x plus 5 equals, now you have to know what this means, people. Please, by now, you should know that you do this. You have to know that, okay? There's no way around that. This means this, and that means double distribution. Okay, continue. X plus 5 equals x squared plus 5x plus 5x plus 25. And then here you combine the middle. Okay, rewrite things. X plus 5 equals x squared plus 10x plus 25. Combine. Minus 5 minus 5 minus x, cancel, 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 cancel. 0 equals x squared plus 9x plus 20, and that is 5 and 4. Yes. 0 equals x plus 5, x plus 4. Nice. Two solutions are, if you make that equal to 0, eventually you'll have that x equals -5 and x equals -4. So, with those in mind, this is actually the lengthiest video. Sorry, I'll try to make it under 12 or 11:30, something like that. So all you gotta do is just check whether these two are valid. Which one? It could be one of them could be extraneous. So -5 first. The square root of -5 plus 5 equals -5 plus 5, and actually this works out nice. The square root of 0 equals 0, and yes, 0 equals 0. Check. Now for this one, -4. Let me just do it over here. So -4 plus 5, the square root, equals -4 plus 5. This is the square root of 1 equals 1. Oh, look, nice. 1 equals 1. No extraneous. They both work out nicely. So there you go. This is a nice, gives a positive answer. This is 1. 1 equals 1. Nice. They both work out. So no extraneous solution here. But this did have one. So sometimes this happens. Sometimes you just get a number. Or sometimes you just get both of them correct. Okay, thank you. Sorry, I just meant to give you this one right here. This is your last practice here, 9R, evens only. You see the setup for those, okay? That one you really see it solved. And they both work out because they passed the extraneous solution testing for that. And then you go ahead and do that. Evens only, please. You see that one ready for squaring. A lot of them are just ready to square. Be careful with this one. It's a little bit tough one. You can kind of see it like that. Okay, this one. Be careful how to do this. Okay, do your best for these. Some of these are a little bit tough like that. Okay, and that's the last one, the toughest one. All right, thank you.